Right, welcome back. So, what are we looking at here? We're looking at a triangle, and we have loads of information here, and let's see can we find any of these cool things about it. So, we need to first of all find SG. Let's find XG. Where is SG? SG is here. So it's the opposite side. I don't have enough to use the sine rule because I don't know those angles, but I can use the cosine rule. So SG will be equal to the square root, using our algorithm, of the other two sides squared and added minus twice their product by the cos of the angle in between. We need this to one decimal place. That is by 4.4 meters. There we go, done. Now, find the angle at HSG. HSG, find this angle. So now I can use the sine rule because I have a pair. So 30 over the sine of HSG is equal to 54.4 divided by the sine of 68. That means that the HSG, the angle, is equal to the sine inverse of 30 times that divided by that. 30 sine 68 divided by 54.4. Right, so 54.4 is 30 times the sine of 68 divided by 54.4, and sine inverse the answer, and we get in 30.75 to 2 decimal places. And there we go. Now I assume the next page is going to have more of this. Let's have a look at the next page. I'm going to keep this here so we can reference it. Find the area. Area is nice. Half AB sine C. So that's half the product of any two sides, 30 by 58 by the sine of 68, the angle in between. We're going to get the answer in meters squared. So that's going to be 806.65. Sorry, it is 65. It is, yeah, 806.65. Done. Find the area of the smaller triangle. Okay, I got a ruler for this one. This one's a bit tougher. So we're going to try and find the area of the smaller triangle in terms of R. So watch this triangle, HPS. I've seen this story before. Okay, oops. Right, mistake there. So let's get this smaller triangle. So let's get the area of the smaller triangle. So to get the area of the smaller triangle, well, I already have the base and I have the height in terms of R. So half the base by the height, that's half of 58 by radius, which is 29 R meters squared. That's the area of that one. Okay, now show that the area of the bigger one can be written in R. Okay, well, let's do the same thing. Look, if I complete this, then I can draw up a perpendicular here, so I can get the same thing there, and I can also do the same thing here. So that'll also be R, and that'll also R. So let's work out this one. So that's going to be half of 54.4 by R, plus the one we know, 29R, plus this one, half of 30 by R. Let's see, does that add up to 71.2? 0.5 by 54.4 plus 29 plus 0.5 by 30, and that is 71.2. That's what it is. So you've proven it. So what's our next thing to do? Find R. Okay, well, we already know the area. So 71.2 R has to be 806.65. To one decimal place, R is divide both sides by 71.2. So 806.65 divided by 71.2 gives me 11.33. Done. Okay, and don't forget the units, meters. Brilliant. Now, is there more? That's part D. Oh, there is more. Oh my God. So let's have a look here now. So they've put a pole or a line from P upwards to a pole. Okay, and they want the height of the pole, of course they do. Now the only thing they're giving us here is that this here is 14 degrees. So there's absolutely no way I'm going to be able to find PT, but I might be able to find PS because PS does exist in my original graph. So if I could find PS in my original graph, I might have a chance. Okay, so let's see what other information I know. If I go back, HSG, why did they ask me about HSG? They told me it was 30.75. So in here we have 30.75 degrees. How does that help me? Well, if you look very carefully, these angles are split by this line. And would you believe it splits it in half? How do I know that? Because look, these are the radii. So that's one side of this triangle is the same as one side of this triangle. This is a right angle because it's a tangent. So there's one side that's equal, okay? And let's have a look. This is a common side. So we have two sides that are common. So that means the third side must be common. So that means that those angles are the same. So let's divide this by 2. So that means I've got that angle, which means if I have that angle and I have R and I have that, I can find that because R is 11 point, what did we work it out? 11.33. So if that's 11.33, let's draw this triangle out just to see what it looks like. And we put out all the information. Right angle. So that's 30.75 divided by 2 in that corner. 30.75 divided by 2, which is 15. So in here, we have 15.375, and this radius is 11.33. And I want this side here. So I have opposite and I want hypotenuse. That's sine. So the sine of 15.375 is equal to 11.33 divided by PS. So let's work that out. Okay, so it's 11.33 divided by the sine of 15.375, 42.73. PS is equal to 42.73. So now that's 42.73, and I'm looking for opposite. TS is opposite that angle of 14, and I have adjacent. So the tan of 14 is equal to TS divided by 42.73. That's straightforward. TS is equal to times tan of 14, 10.65 meters. Okay, so there you go. And one decimal place, okay, one decimal place, 7 meters. There you go, perfect. Right. And we have one more to try. Okay, so use triangle ECT to express TE. So that's going to be a right angle for that. I'm going to draw it out here. Look. There's E, there's C, there's T, there's 60, there's 90, and that would make that 30 up there. Okay, so I need to write TE in the form of root A times where A is a natural number CT. So let's see what we've got here. TE, we've got, we want CT, so we want to use this one down here. So opposite over adjacent, so the tan of 60 degrees would be equal to TE over CT. And we want to rearrange this. So the tan is 60 degrees, I think is root 2 or root 3. It's root 3, perfect. So that means that root 3 times CT is equal to TE. That's done. Show that TE can also be written like this. Ooh. So what I'm noticing there is 225, and I'm noticing 15 there, so that must come into play. So let's have a look and see that. I've got a right angle down here, so let's look at this right angle on the ground. So this right angle on the ground has 15 on one side, the right angle is there, there's CT, so we can we know where CT is, he's here, and this is DT. So what it's saying to me is that, you know, DT needs to come into play here, probably, in order to kind of get this right. Because if I look at it carefully, 15 squared is equal to 15 squared plus CT squared is equal to DT squared, which means that DT would be equal to the square root of this side. Okay? So that's what they're saying there. So we know that 15 squared is 225 plus CT squared is equal to DT squared. Okay, so let's have a look at DT. So DT is made up of this triangle. It's another right angle triangle because the base is there. We've got 30 in the base and we've got ET and DT. So let's have a look. If I want ET and DT together, so that means tan again. Okay, so let's have a look at this. So that means that the tan of 30 degrees is equal to opposite over adjacent. So let's rearrange this in order to get DT on its own. Okay, let's have a look here now, see what we can do. The tan of 30 is 1 over root 2, 1 over root 3 is equal to ET over DT. So DT is equal to root 3 times ET. So wherever I see DT, I'm going to replace it with this. So now we have 225 plus CT squared is equal to root 3 times ET squared. So 225 plus CT squared is equal, let's square this out, that's 3 times ET squared, divide both sides by 3, 225 plus CT squared divided by 3 is equal to, let's call it TE squared, it's the same thing, and I just want TE, so TE, so TE is equal to the square root of 225 plus CT squared over 3. Okay, so there you have it. So I'll go through that again. The first thing I did was I used Pythagoras, because this is a right angle triangle, to show that that squared should be DT squared plus CT squared. That's what that is. That squared is 225, CT squared, we need to keep that, but DT squared needs to be converted into TE. So you do that using this second triangle. Look, I've written it out here. The tan of 30 is TE over DT. Tan of 30 is 1 over root 3. Rearrange it to get DT, substitute it in, square it out, and rearrange to get the answer you're looking for.